everyone. I'm Nick, for those of you who don't know me, I'm a researcher in the University of Grenoble. And I will show you some examples from our Lan.d.s platform, which is short for Languages and Domain Syntax platform. But before we get started, a little bit of background as to why I am building Lan.d.s. This last 2 or 3 years, I'm doing a lot of language parachuting, which means I fall from the sky inside a computational science group that may be doing epidemiology, or geography, or civil engineering, or even system programming for the Linux kernel. And together with colleagues that are not language designers and with experts from these fields, we build domain-specific languages for the experts and their users. And when I am lucky, the end result will look something like this, which is a DSL that we've built recently for geography, where the domain expert would be able to lively edit the DSL and see the results as he's using the platform with his users. And the users can check the statistics, play around with widgets to understand their problem and their model with integration with GIS, for example, etc. Now, I'm trying to build these platforms in what is called a participatory modeling approach. It does not always work. It means that we build the language together with the stakeholders, and there are things that are getting in the way. One of these things is fighting with parsing tools and having to explain to people that don't care at all what is shift reduce or reduce conflicts, and why I cannot use left recursion with this PEG parser here, and why they cannot express the grammar rule as it is in their head. So a thing that I'm doing differently in Lan.d.s in order to address these issues is allow, and here is a small example, allow from the beginning and during development to express the grammar as you have it in your mind, which can be ambiguous. And we embrace this ambiguity because it's our current understanding of the language, which means it's our current understanding of maybe the problem. And instead of getting technical with people that don't have the background for the reduced conflicts, we just go together through the different parsing trees and what this means for their current understanding of the language lively. And for those of you who may have noticed, this is done inside an interactive document. The grammar is here, and it's embedded already inside a general purpose language. This is Faro using the system itself. So this is the alpha version, but we already eat our own dog food. Okay. Now, having this ambiguous grammar definition, of course, can be a problem. It's very good during development in order to understand the issues. But then with the same parsing algorithm, we give you ordering choices, 3 different flavors of ordering choices in a formalism called multi-ordered grammars, which in most cases would allow you to just edit the kind of ordering choice from an ordered choice to one of the multi-ordered choices that we support with our parsing algorithm in order for you to disambiguate. And I will go ahead and embed the result inside the document. And of course, you can check the differences together with the users from the ambiguous version to the disambiguation of the parsing tree incrementally. Of course, parsing is half of the story. The other half, at least, is generating something meaningful. And for the case of languages and domain-specific languages that have some executional semantics, what we have introduced is a DSL, a small DSL, again, inside Faro, for generating ASTs. We call it the abstract syntax language, and it defines a set of operators that allow you to do things similar to quasi-coding and splicing in functional languages, but in an object-oriented way. Because there were previous attempts to adopt quasi-coding for object orientation. They didn't catch on, so this is our new attempt to define object-oriented operators that will do the same job as quasi-coding. And once you have these actions with ASL, you can lively, of course, let's put it down here, go and inspect the resulting parsing tree. And this is now the AST of the host platform. This means that the language that we just built is at the same level as the host language. It generates the same AST nodes. It will be byte compiled and use the JIT compiler of the underlying VM. It's at the same level with the host language right now. Okay. Continuing this interactive exploration, of course, you can now, let's put it on the right, evaluate expressions for the underlying platform, and with that, you can write small assertions and unit tests. Now, if you don't like interactive documents, you may want to organize your grammars into classes, and this is something that other frameworks, especially for Smalltalk, do. The only difference here is that, again, we have embedded the syntax for the grammar themselves in the language, so I can write now classes where the methods are grammar rules, organize them into hierarchies, and, of course, use ASL to generate the AST for this simple language. Okay, but can we handle more complicated scenarios? One level of complication above is when you will have multiple ambiguities, and this is a simple calc language, imperative language that exhibits both the expression ambiguities here, and the dangling else ambiguity here. And the workflow is exactly the same. We have a grammar defined in a class that uses these MOG operators for recursive ordering. And you can explore initially the ambiguities and then incrementally disambiguate. I have a small example. This is the collage numerical series algorithm just to test the dangling else ambiguity. We generate the abstract syntax tree for the underlying platform. Of course, you can inspect everything in the document itself. And evaluate, you can see the results here in the bottom, evaluate the algorithm and the numerical series that gives you the correct result. But what I would like to focus on is this example. Don't worry if you don't know Smalltalk. The point that I'm trying to make is a little bit different. The upper part, the brown part, is just a string with code, and it's a specific method that is very known called the Smalltalk postcard, because it covers most of the syntax of the language. That Smalltalkers are very proud to say that their syntax fits in a postcard. And I give it to the Faro parser, and the compiler, they give me an AST back. And at the bottom, you see the same AST written manually with ASL. So what I want to show here is that for 2 lines more of verbosity, I have the ability with these operators of ASL to describe very naturally, as in quasi-coding and splicing, the AST for the whole Smalltalk syntax. So we saw the grammar, and of course, you guessed it, we can level a little bit up and have realistic examples like a full Faro parser. We followed the same workflow here. On the right, you see the exploration of ambiguities using an ordered choice, and then the disambiguation embedded in the document. One thing that is interesting here to note is how we express the main abstraction inside the Smalltalk language, which is the abstraction of the message sent. This is, like we describe it in natural language, a message sent is an expression that is followed by a message and one or more cascade messages. So these are dynamic method invocations. And this is exactly, it reads exactly as we will describe it in natural language, written in multi-ordered grammars. The same for the notion of a message. So a message will be either a keyword message followed by expression, a binary message, or a unary message. We were able to disambiguate these simple rules instead of doing this, which is what the PEG equivalent for Smalltalk does for messages and message sends. This is the description for from the ANSI description of messages and messages for Smalltalk, and this is an LALR parser doing the same thing. Of course, to avoid conflicts, ambiguities, and other problems, they had to write a layered kind of grammar. With multi-ordered grammars, we are able, in most cases, to be more concise than that. Okay, so once you have your parser and you have AST, one thing that normally you want to do is to share solutions among your projects. And we do this with GrammarTraits. We have extended the notion of a trait in order to describe grammar rules and grammar actions. So here you see the whole parser for Faro decomposed in 10 different grammar traits. And the things that you can do with GrammarTraits, we can see it here. This is again the message sent. But you see, I only defined what is a message and a message sent and not what is an expression. So what is an expression can be defined by someone else. And the final composition will decide what an expression is. I'm just describing here what a message is. So here for this grammar trait, expression is a requirement. And of course, because we are using traits, we also have the algebra of disambiguation of traits, which means that when we have conflicts, we can use exclusion to remove conflicts from one side, aliasing for renaming, or overriding. And we use this to actually extend Faro itself with imperative semantics with for, while, if statements, return statements, method invocations, imperative method invocation, and functors. That means objects with a call operator. And this is some of the results where you can see the same Faro and Smalltalk postcard written in mixed form with object-oriented syntax and imperative syntax. This is from an alternative universe where Smalltalk adopted mainstream syntax and Java was never born. Now, okay, I have some time with GrammarTraits and multi-ordered grammars. We can more easily build the DSLs for geography and epidemiology that I discussed. One thing that I should note here is that we are able to annotate the grammar with state operators in order to create also from the same definition the meta model, so that the meta model and the grammar are in sync. And last but not least, we have Lise, which is a functional first multi-paradigm programming language for the underlying VM. And what we did here with Lise is try to break our abstractions. So I tried to break this composition of grammar traits. I tried to break multi-order grammars in order to see how far we can go with paradigm composition. So this is again the postcard. It's Lisp-like. Okay. This is not a simple interpreter. As I said, this sits at the same level as the host language right now. Okay. And we have smiley scoping, so we are able to call functional invocations from within Faro and Faro invocations from within the Lisp-like syntax. But also, because of this composition and because we are in a polymorphic dynamic environment, the head of functional invocations can be either lambdas, as you see here, but also any other object. Because this is a dynamic invocation, I will send value to our objects or our symbols. And this is an interesting thing that arose out of the combination of multiple paradigms. We have a test suite for Lise, of course, and the mix now here in this postcard of all three paradigms that I described previously: imperative, functional, and object-oriented. And one thing that actually broke, but it was interesting how it happened, is described here, and I will end with this. We were able, through this composition, to define and scope object-oriented code and functional code without using an explicit scoping. And we didn't anticipate this, okay? So this is maybe a bug or actually a feature here. And we are in the process of determining what this means, but for the time being, we call it emergent semantics, okay? So that is all from me. Thank you very much.
Questions? So interesting talk. Can you give any guarantees when you have ambiguous languages that you can always disambiguate some programs?
The same guarantees that we can have for the linguistic abstraction of traits. So there is a formal algebra for traits that describes in the initial paper by Dukas and Oscar and their student. But guarantees for the DSL, if you give me to DSL and do an analysis, I cannot guarantee that you will be able to resolve all conflicts. Of course, it will not go to the end of product. The system, by the semantics of traits, will actually raise an exception when you have a conflict. It will not result in a logical error. You will see it very early in your testing phase.
So these multi-ordered grammars that you have?
Yes.
I'm wondering, so they were for disambiguating, essentially.
Yes.
In the parser. I'm wondering how they compare expressiveness to other approaches to doing this. For example, SDF has disambiguation rules, so is it similar in expressiveness or different?
There are similarities, and there are similarities with other works as well. So, for example, there is from Nicolas Laurent in Belgium that he's building extensions to the PEG parser and the PEG algorithm. One thing that is different is this incremental disambiguation. So the fact that the same algorithm allows you to have something like a chart parser, like an early parser, and at the same time, you just change the ordering of a single subrule, and you see the results lively. So the philosophy here was building the notation together with the tooling in order to produce this effect. From another perspective, what I have seen, because there are ALA, LR, and PEG parsers available for Smalltalk, and handwritten parsers as well for a variety of languages, that in most cases I was able to more concisely, as I showed an example, describe core rules like the messages and the message sense, or even the expression grammar here.
Final question, maybe? If not, then I propose we thank Nick again. Thanks.
Thank you.